Okay, so today we're going to talk about derivatives of exponential and logarithmic functions. And the first question I want to ask today is what is a general, right, or a typical exponential function? What's the general format? Well, here's the answer. General format is going to be f of x equals a, sorry, f of x equals a to the x. Now here a is a real number. Okay, and our goal is going to be to come up with the formula for f prime of x. So what's the derivative of an exponential function? Now, if we're going to compute the derivative, that means we need to use this equation right here, or not this equation, but this formula, right? So we need to use our limit definition. So we have f prime of x is equal to the limit as h goes to 0 of this difference quotient, right? And remember, this is a difference quotient because it's a quotient because you're dividing two quantities, and it's a difference quotient because the numerator is the difference or the change in your function f. So now let's fill this in for our function. So remember, f of x is equal to a to the x, and we're also going to need f of x plus h. And what is f of x plus h? It's going to be a to the x plus h. So now we are ready to plug in. So we'll have the limit as h goes to 0, a to the x plus h minus a to the x divided by h. Now, we can write this as the limit h goes to 0, a to the x times a to the h minus a to the x over h, because remember we're using our exponential rules, our rules of exponents. Now we can factor out in the numerator, we can factor out a to the x, and we'll be left with a to the h minus 1. All of that is divided by h. Now remember, we're taking the limit as h goes to 0, so this a to the x is essentially a constant because our limit is involving h. So a to the x has nothing to do with h, so we can just actually bring it right on in front. Right, we use our limit laws to say this is equal to a to the x times the limit as h goes to 0 of a to the h minus 1 over h. But now wait, let's see here, look. Do you notice anything? Look right here. Do you notice that this is the same, this limit is the same as, so this limit is same as f prime of 0. Okay, and let's just double check that. Right, what is f prime of 0? F prime of 0 is going to be equal to the limit as h goes to 0, f of 0 plus h minus f of 0 divided by h. Okay, so back up here, what is f of 0? If f of x is a to the x, f of 0 is a to the 0, which is equal to 1. And f of 0 plus h is going to be equal to a to the 0 plus h, which is a to the h. So we'll plug those in here, and we'll get the limit as h goes to 0 of a to the h minus 1 over h. And that's exactly what we have over here, right? So the bottom line, is that f prime of x is going to be equal to f prime of 0 times a to the x. Okay? All right. Now, I would like to point out our first fact that we're going to use today. First fact is that there are 3 ways to define the irrational number e. Okay, so what's the first way? The first way is to say that e is the limit as n goes to infinity of 1 plus 1 over n raised to the nth power. And now we might have seen this. You might have seen this from, let's see here, Algebra 2, when you're defining continuously compounded interest. Okay? And now, let's look at the second way that E is defined.
It's 1915.
Thank you. The second way E is defined is as an infinite series. So this is the notation that we write. The sigma from n equals 0 to infinity, 1 over n factorial. Now here, as an infinite series, we're going to get into this next semester. So this is actually the definition that's given in Calculus 2. And the last one is the one that we're using today and for this course, which is to say that E is the solution to the following problem. And here's the problem. Suppose you want to see when is the limit for what value of A is limit h goes to 0, a to the h minus 1 over h equal to 1, right? So if that's the question, for what value of A, the answer is call whatever value makes this equation true, call it E. Call that number E. So whatever is the special value where this limit is equal to 1, for whatever value of A, just let that be called the number E. So what does that do for us? Well, looking back, now this means for f of x equal to e to the x, f prime of x is going to equal e to the x times f prime of 0. But now remember, that's e to the x times 1. Now why is that? Let's look back. So what we have here is, well, I like this little zoom in box here. So remember here, the bottom line is that f prime of x is equal to f prime of 0 times a to the x. And what we have is, we have a equals e, right? So f of x is going to equal e to the x, and f prime of x is equal to f prime of 0 times e to the x. But what is f prime of 0? F prime of 0 in this case is going to equal this limit. But remember, e is the special number where all of this is equal to 1. So that's how we chose to call it e, is we said we need to have this limit equal 1. So that means that f prime of 0 is equal to 1. So we have, here's the bottom line. Let me go to a big marker here. The bottom line is that the derivative with respect to x of e to the x is just equal to e to the x. Okay? And similarly, let's see here. So similarly, we have that the derivative of a to the x, right, for any a, is going to equal the natural log of a times a to the x. Okay. So those are the rules that we want to remember. And now let's go on to fact number 2. Fact number 2. Fact number 2 states that if, so let me actually use my little box. If f of x and g of x are inverses of each other, then g prime of x is equal to 1 over f prime of g of x. Okay? So now, do you remember what it means for two functions to be inverses of each other? Okay? We talked about this in the first 2 weeks of class. This is our, during our review. So let's go and look at this now. Remember, your inverses, f and g are inverses of each other if f of g of x is equal to x, or g of f of x is equal to x. Then f and g, f of x and g of x, are inverses of each other. So we're going to use this to come up with the inverses for our trig functions and for our e to the x, our logarithmic, our exponential functions. So let's go ahead and do that now. So let's use that role back to determine the derivative of log functions. Why? Because what's the inverse of an exponential function? A log function. All right, so let's go ahead and do this. So we're going to let f of x equal a to the x, and now g of x is supposed to be the inverse of x, right? And what is g of x? If f of x is a to the x, what's the inverse of a to the x? Log base a. Okay, now our formula, or using fact 2, we'll get that g prime of x, in fact, let me just copy, and paste it here. Okay, so g prime of x is equal to 1 over f prime of g of x. But now what is g of x? G of x is log base a of x. So this is equal to f prime of log base a of. But now what's the f prime? If f of x is equal to a to the x, then f prime of x is equal to natural log of a times a to the x. Natural log times a to the x. So f prime of log base a of x, everywhere you see an x, let me just highlight this. Everywhere you see an x, place it with base a, okay? Natural log of a times a to the log base a of x. Now, do you remember your properties of logs? A and the log base a, right? They're going to cancel each other out because because they're inverse functions. So we're going to get natural log of a times x. So back to our formula over here with g of x, we'll get 1 over natural log of a times x. So now let's look at our derivatives so far. So what we've done is we have derived a formula for the derivative of logarithmic functions. Okay, so let's see here. So our formulas so far, let's see if we can put them down. So we'll have, I'll put them in a nice pretty box here. d dx of e to the x equals, what is it equal to? E to the x. Now, d dx of a to the x, well, we're going to run out of room. I wrote too big. So let's put it on a second one here. d dx, sorry, d dx of a to the x equals natural log of a times a to the x. So now this is a constant, right? Does everybody get that? Constant. Okay. And our third one is d dx of log base a of x equals 1 over x times natural log of a. And our fourth one is d dx of natural log of x is equal to 1 over x. Okay? So we'll have this is 1, 2, 3, and 4. Okay, so these are our derivatives so far. Now, let's do some examples. And I'm actually going to turn to a new page so I can have a fresh start. And no, I'm not. I got to charge my stylus. I'll be back.